recording. Up until now, the first chapter is over. Today we start with chapter 2. Hooray. What did we do the second day of class? So we started with fractions and order of operations. That's sort of review in my book. What was the first real thing that we did? Second day of class. What was the topic of discussion?
Solving linear equations in one variable.
Okay, so we solved some type of thing, and that was called an equation. What made the thing we were solving an equation? It had a what in it? Equal sign. So we started with solving linear equations in one variable. Then what happened a couple of days later? What types of things that we start playing with? What two variables? Sorry? No. Something in two variables. Something in one variable. She just said it. I just said it. Linear equations in one variables evolved into something in two variables. Linear equations in two variables. What came after that last class? What did we discuss in the last class on Monday? Systems of linear equations, so that we had two equations and how many variables? Two variables, two equations, right? So do we see how we started with linear equations in one variable, solve for x, solve for p, solve for q, whatever? Then that changed into, hey, here's an equation, x plus y equals 6. What types of things did we do with those types of equations? Found their... Sorry? Sure, we found solutions of two variable equations. What else? What else did we find with y equals 6 plus x, let's say? Slope. We found slope. What else? X coordinates, y coordinates, which is really part of a solution. What else? We found x-intercepts, y-intercepts. Do we remember all this stuff? All that's going to happen again in the second chapter. So if you didn't learn it for the first test, better learn it now, or the same result would occur again. So today it will be just an introduction to inequalities, which are things that are not equations. And we'll talk about graphing them. We'll talk about how to write the answers in interval notation. But starting on, what's today? Wednesday. Friday we'll solve, what do you think we're solving? Linear blank in one variable. Not equations. Equations of chapter 1. Linear inequalities in how many variables? What do you think will happen next Monday then? Linear inequalities in two variables. What will happen on the following Wednesday? Do we see how it's the same junk but just with inequalities now? So everything we did in the past, we're not going to reteach it. I'm going to assume that you know how to find intercepts, you know how to graph lines, yada, yada, yada. So here's the beginning. There are 4 types of inequalities. One of them is less than. What other 3 types do we have? Less than and 3 others. What else? Greater than, more than. That's 2. What else? Less than or equal to, and one more. Less than, greater than, less than or equal to, greater than or equal to. So we'll do less than and greater than together first. And this is on the website. You can take notes on it if you like, or I'll just send you the link. Less than, if you're writing an inequality, you use this symbol. Is there anyone who hasn't seen that symbol before? I hadn't until I came to the United States. We use different symbols in India. So you have? Yeah. Is there anyone who hasn't? So everyone's familiar with that being the less than sign or symbol? Okay. When we're graphing things that have less than in them, we always use this open circle or a hollow dot, whatever you want to call it. But it's a non-filled in circle. It's just the circle with nothing inside it. And then when we're writing intervals or using interval notation, we always use parentheses. Let's see this in action. So let's say that you solve a problem and then you end with x is less than 5. if I wanted to graph this, what number is the number of interest? What number is sort of the dividing line between things that work and ones that don't? So what should I put in the middle of the number line then? No. What number? Does that seem reasonable? What you don't have to do is start at 0. There's nothing special about 0 anymore. I don't know why people think that 0 is special, but there's nothing special about 0. So you don't have to start at 0 and then make 5 hashes and then say, oh, this is 5. Because what happens if this were 0, x is less than 500? Are you going to start at 0 and then make 500 hashes? No. What number do you stick in the middle of the number line then? 500 or whatever the number is. Now, because it's less than, what should I put above the 5? Open circle or solid dot? Oops. Open circle? Now, which numbers are less than 5? Give me examples. 4, 3, 2, 1, 0? Negatives? Where do all of those numbers live relative to 5? To the left or to the right? So that's the direction in which the solution arrow goes. So this means, how many solutions are there to this inequality? X is less than 5. Infinitely many. And what are all of those solutions? All the numbers less than 5. We read graphs, including number lines, in which direction? From where to where? Always left to right. So when we write this interval, or actually before we get there, if you walk all the way to the left on the x-axis, what number do you see all the way down to the left, where you can't walk any past further? No, you can walk past 0. -1, -2, -3. So what happens if you walk all the way to the end of the number line? What number do you get to? Someone will spring it. Infinity would be the other direction. You need to move to the left. So all the numbers to the left are, so what number would be all the way to the left? Negative infinity is all the way to the left. What happens if you walk all the way to the right? Infinity, positive infinity. Fair? When we write intervals, we always write them from left to right, just like we read graphs. So where does the solution start? What's the leftmost number that's a solution? Negative infinity. And when do the solutions stop? So when we write the interval, does it seem reasonable that the interval would be negative infinity to 5? Also, do we remember that with open circles, we always use what symbol? Parentheses. We never use brackets with open circles. Are we okay with this one? Can I pick up some steam with the others? Everyone's good? Okay. These should go a little bit easier and faster. So the next type is greater than. We use that symbol. Hopefully that's not a surprise to anyone. We still use an open circle. We still use parentheses. So less than, greater than, we use the same symbol. Just open circle and parentheses. Fair? See this in action. X is greater than 5. What number do I put in the middle? No surprises there. Open circle, closed circle. Give me examples of numbers that are greater than 5. Where do those numbers live relative to 5? To the right, so solutions live to the right of 5 on the number line. How would we write this as an interval? So we start at 5, and then where do the numbers stop being solutions? So 5, comma infinity, both parentheses. Questions? Which way do we read graphs and intervals? Left to right, always. Next thing, less than or equal to. So here, do we see it's the less than symbol with a half equal to sort of fused into the bottom? Now, for less than or equal to and greater than or equal to, we use solid dots. And in the intervals, we use brackets, square brackets, not parentheses anymore. Are we all good so far? Let's see this in action. So x is less than or equal to 5. What number goes in the middle? Pretty easy now. Open circle, solid dot. Solid dot. And which way does the arrow go? Because numbers less than or equal to 5 are to the left of 5. What would be the interval? What's the leftmost number that's a solution? Negative infinity until, and then on 5, what symbol will we use? Parentheses or bracket? Bracket. So that's the answer in interval notation. Now, before we go too much farther, do we see that these three things mean the same exact thing? There are three different representations of the same answer. The first one is an inequality, because we don't have equations here. Whoa. Sorry. The second one is a graph, and the third is the same thing, but an interval notation. So from now until the end of the semester, you have to be comfortable moving from one to the other forms. So today we'll get enough practice to where I'll first give you the inequality, and you'll have to draw the graph and write the interval. Then I'll give you the graph, and you have to go to the other two. Then finally you'll get the interval, and you'll have to write the graph and the inequality. Lastly, no surprises here. Greater than or equal to, use a solid dot, use brackets. Are we good with that? X is greater than or equal to 5. What number goes in the middle?
5.
Solid or open? Solid. Arrow to the right. Interval. Now, something hopefully that you've noticed, or maybe not. What do we always put around infinities? Positive or negative? Doesn't matter which one. Infinities never get brackets. You can only use bracket when you're including a number. Infinity is too big. You can't get your arms around it. You cannot ever include it. So infinities will only ever get parentheses, positive or negative, doesn't matter. The finite number that's on the other side, that gets either a bracket or a parentheses based on whether it's less than or equal to. Are we all okay with that so far? Just a couple of quick reminders. If you make sure that your variable is on the left side of the inequality, your arrow will go in the same direction. This only works if the variable is on the left side. What I mean by that is the variable on the left side of this inequality? Which way is the inequality pointing? Which way is the arrow going? Is the variable on the left? Which way is the inequality pointing? Which way is the arrow going? As long as your variable is on the left-hand side, the inequality and the arrow will point in the same direction. Fair? So what happens if the variable is on the right-hand side? So if, let's say, you have 1 is less than x. How do you rewrite it so that the variable goes on the left? 1 is less than x. Does that seem reasonable? If Alexa has more money than I, then I have what than Alexa? Alexa has more money than I. I have less money than Alexa. Does that relationship make sense if we flip it around? So if 1 is less than x, doesn't x have to be greater than 1? So all you have to do is just flip the direction and everything stays the same. Another reminder, when you're reading the graph, which way do you read it? Left or right? When you're writing an interval, what do you always put around infinities? Parentheses. This is less a concern, but the smaller number always goes on the left-hand side. If you always read from left or right, you don't have to worry about that. And then number 5 we'll get to later. I just threw it in there, but we won't need it right away. Questions so far? Okay, then I will pause here.